Welcome, I'm Bill Wake. We're here working on a new programming language called Tenth. We've developed the compiler and interpreter for it, and now we're going to try it out in an application, HANGMAN. So if you've never played this game, on the top line there's a guess, and it starts out all dashes for the length of the word. So, if I hide a word, I make up a word in mind and write out the number of dashes to correspond to the letters, and then we put an empty scaffold and we start you start guessing. And if you get the letter right, like N, it goes up into the word replacing the dash. If you get it wrong, you start accumulating the body that's being hung. So you start with the head and then the torso and then so on. And if you run out of letter, or if you run out of body before you run out of letters and you've guessed the word, then your guy is hung and you lose. If you guess the word first, you win. Okay, so what I'm anticipating is we have probably 95% of what we need in our language to do what we need to do. There might be a couple things we have to add, and if so, we'll add them as we need to. But otherwise we'll be up in this 10th language. Now, I did look up a little bit of research. There's a link for some VT terminal code, so we can position our cursor and do things like that. So let's dive in. All right. Before we do, let's do a make. I think we've left everything okay. And see any red? Any partially run things? No, it looks good. Okay, and I don't know if, have I changed anything? Oh, just that. Okay, we'll let that go. Excuse me. So, let's see. Well, we're going to do this in a new file, and I guess we'll just make a folder for it. New group without a folder. Let's call this 10th for our 10th code. And then inside there, let's add a file. And I think we'll just do a text file. Empty file is fine. Okay, and this is hangman.10. Now, one of the things our language doesn't have is it doesn't have file input. So we can use redirection from Unix, and I started to try this and something looked a little fishy, so we have to fix that. But let's see. So if I do /REPL.out input, double input here, that takes my text until I hit the word here. So 1, 2 plus print. 2, 3, 4, 2, 3 times, 2, 3, 4 times plus dot is 12 plus 2 is 14. So the first one should be 3 and the second one, or first one 3 and the second one 14. Okay, so we got the 3 and the 14, but end of file, we got some other complaint. And I'm not sure why. Let's try and characterize it a little bit. Now, let's just start with the simplest file, right? Empty file. Okay, so something's not working there. Well, let's make sure REPL.out. And I lost my text. There we go. Okay, so blank line should be okay. What about Control D? Aha. So Control D is end of file. Normally we do Control C to just get out. What else? Control Z. Yeah, we can do foreground. And that's also not good. Okay, so I think Well, let's ignore it for a little bit. I'll put it on the list though. Where's my to-do? Today's number 39. Tax day in the US here. Okay. So this is really still an input question. Well, actually the question's already there. Read from a file, gets error at end. This is really not, it's really redirected input, gets error at end. Read from file, not supported. Okay, so that's the one I don't quite trust. Well, we're seeing an error, I should say, put it that way. Yeah, here, yeah, I don't know if that, I'm not quite sure the internals. I don't even know if it's guaranteed to be the same between Unixes even, but at any rate, you know, it's reading until it hits that here. I don't know if it's creating a file, a temp file, or if it's just maintaining characters in a pipe, in a Unix pipe, or what. But it is very similar to a file. Actually, that's probably a good thing to try, right? Let's cat test.10. Well, we can do that here. Input here. 1, 2 plus here. Whoops. Cat input here greater than test.10. 1, 2 plus 2, 3, 4 times plus dot here. Okay, so that should only print 14. But let's dump this thing. OD minus C is octal dump with characters. And I think I can do both. Get hex 2 of test.10. Okay, so we're interesting. We're seeing 1, 2 plus, new line. Oh, X is not doing by bytes. Okay. But I mean, 0, 0, 0. Let me look up my OD. Is there a way to get characters, bytes, octal shorts? Oh, C style. That seemed like what I'd want. Is there minus B? Yeah, let's do that. OD minus C minus B. Test.10. Okay, so, I mean, this looks, it doesn't look like it has an empty character at the end. Well, dot/REPL.out. It looks like it has a new line, both these places. It defaults to octal, so 8 plus 2 is 10, which is right. 40 is a space. Okay. Input test.10. It does it, and then it gets word not found twice. And then a bus error. Yeah, I don't know. Is it UTF-8? Well, it isn't. It isn't, right? We're just doing regular ASCII characters. We haven't done anything fancy. So UTF-8 is only kicks in above, you know, once you get into 8-bit bytes and stuff. Yeah, 40 is octal 40, so 4 times 8, 32 is a normal space. Yeah. All right. Well, I think I'm going to get annoyed pretty quickly, but I just don't feel like debugging right away first thing. All right, let's go back to the picture. That's a good place to start. So what we're going to do is at the start of the game, we're going to just we're going to choose a word. We're going to write that many spaces. We're going to draw this scaffold, and then we're going to write the word guest, and maybe, I don't know, something to quit. So that all feels like stuff we can kind of do. I mean, given the word, we could do this, I think. So I think I want to I kind of want to say, given the word, draw the initial state. Okay, so let's work on just stuff. All right, so this is Hangman. All right, so one thing is, given the word, draw the initial dashes, draw the scaffold, draw print guest. That's all before you do any reading. Okay, then we're going to read a character. Read character. I guess there's three cases, right? Ignore, well, if not in, well, if it's already used, ignore it. If it's in the word, place it in all places. And if not in word, draw next body part and add guess to list. I don't know. I think it's normal to not put guesses that succeeded in here. I don't know. We'll maybe do it that way. All right. And then I guess it's like if the word is guessed, you win. If out of body parts, you lose. That's kind of the whole thing. Okay. And I guess we could print Hangman at the top. That would be simple. Okay. Well, I don't know. I almost want to define. Well, I said we'd do it TDD, so let's figure out what that is. So, let's define. Let's define tests, and we'll stick everything in there. All right, and we'll make a test. Title. And test for title is, well, if you call title and then push Hangman, then I guess assert equal strings. Okay. So I'm assuming I'm not going to worry about the print part. I'm just going to get the pieces right, and then we'll start printing. And printing's more of an I/O thing. I'm not going to sweat that one too much. Okay. Now, we don't have assert equal strings. I don't think we can get it. Already we're... So, well, let's put the unit test stuff up here. So, assert equal strings, and then ends there. And our test, the only test we have is test title. Okay. Now, I think that's kind of ready. Okay, so assert equal strings. Well, let's go to README. Let's look at that one. I think I've got it up to date. All right, now I kind of know. We don't have string stuff. We just have print a string or make a string. Now, if the question is like, what's the best way to do this? We could create an equal string assertion or comparison, just like we have. I think it's equal equal. We could have equals equals for strings, or equal equal $. That might be simple. Another way would be like, how do you implement equal equal? Well, it would be nice to have something that peeled off the first character of a string, and then we could do equals equals on that. Normal equal equal. So it's like, how general do you want it to be? I don't know. I mean, I guess in a sense, everything we can do if we can do it in the core, or I guess I'm saying, if we can build it out of stuff that's already done, that's kind of nice. But I don't think we have a good way to do that for the string one. All right. So, I guess what we need to do then is implement. Well, I'm thinking of something to iterate through a string. I called it split before. I don't know if that's a very good name. That name's kind of taken. Where's to do? Strings, relocatable addresses. Well, that's good. Oh, split and join. I mean, join kind of plus would be good for that. Something to read a particular character. Split. I don't know what you call it. It's not really iterate exactly. Well, head is the other choice. I think a head. And then head, yeah, we don't have string length either. I'll say pound S, pound dollar is string length. And then this one I'm going to call head. And I think if we have head, we could get string length. So I'm kind of thinking of this as the more primitive thing. And I think we'll want join dollar. All right, so down to the programming level again. String tests. And I mean, I'm not surprised we need this. It's kind of a basic thing. All right, but what is it? Well, head splits first character from string. Okay, so my idea for this, the idea would be you'd put a string on the stack, and it would pop that, but push the string that's one shorter on the stack, and then put the character that was in the front on the stack. Okay, so I'm just kind of leaving it around. All right, so I guess we don't. Okay. Yeah. I don't even think it matters that it can be data. This is head string. Okay, let's just do cab. All right, and then we need P align 2. Okay, so let's I can never remember the name of this thing. Data stack and head. Act is calling head string. Okay, and we want to push. Well, let's load address. X0 is L head string. And data push that address onto the stack. Okay, so we're going to call that, and we should be able to say data pop X0, move X1 gets 67. Letter C, be assert equal. Okay, so that says the top of the stack is the first letter, and then we want to assert equal strings. Yeah, so we'll data pop X0 and load address X1 is L head expected. And BL assert equal strings. Okay, so put that up here. Is ASCII Z AB. Okay. Good. Create a data stack, load the head string, push the address onto the stack, call head string, pop that first thing off the stack as a character. It's just a normal integer as far as we're concerned. Make sure that's right. Then pop the second thing and make sure it's a string that equals AB. Okay, and string.s. I guess I need to be consistent. Okay. Okay, and add this test. Whoops, let's see. Should have a failing test, but that's a little too quick. How unexpected. Did I leave out the colon? Yep. All right, there it is. Head splits from first. That fails. And then it completely blows up. Okay, good. That's progress. Okay. Well, head string. Clearly it's gonna pop. Well, okay. We haven't said what happens with empty strings, but let's just go with what we got. We do a data pop. That's x0 is the pointer to string. We're going to let's move. Well, we want x. I guess we'll do a load byte. X1 gets whatever x0 points to. Okay, so that's that first character. All right. And actually, we can do a post increment. Add one to it. Okay. And now we can do a data push x0. That's the new address, one forward, and data push. I'll say x1. Okay, so pop the address, look up the byte pointed to by it, and increment it. Push the incremented address, push the character as an integer. All right, and I think this should work. Yeah, okay. But we haven't said what happens with an empty string. Which in some ways is probably the case before it. Test start head does something with empty string. Okay, would help if we defined it. So I don't know. I guess the two choices. One choice would be if you say head of an empty string, we could blow up. Okay, that's a valid choice. Don't do that. Another thing we could do would be we could say when you take the head of an empty string, well, that's okay, and you'll get a zero. You'll get a pointer to the past the 0 byte on the stack, and you'll get the 0 character. In a way, I think it would be better to not push the string back on. Yeah, we want the 0 on the stack because if we're writing a loop around the string, we want to know when it ended. Okay, so I think it should push 0 on the stack. Empty string pushes 0, but not string. So that's a little weird. It's saying when you write this, use this thing in a loop. Well, we can't push the pointer after the 0, so that's a garbage thing. Yeah, we'll know it's at the end of a string, so theoretically that's fine. I don't think there's a meaningful address. We could leave it pointing at the 0, but that sort of invites a loop. The only thing is we're making the stack unbalanced in the sense that while you're using head, it's got that string on there. When it gets to the end, it pops it there and you're done. But I think that kind of fits the way you'd want to use it. Because you could consume the character and then, like at the end, you'd have to pop off this useless pointer. So I don't know. We'll try it. All right. So this setup is somewhat related. So let's just steal it for now. Okay. Okay, initialize the stack. We're going to point L empty string. Okay. That goes there. That gets pushed. All right, head string does its thing. and we pop, and this thing should be a 0 byte. Terminate string. Okay. But there should not be another string there. So let's push a random number, or an arbitrary number. Move x0 gets 42. Data push x0. I'll just call this a guard value. And then we pop x0, and let's move x1, 42, assert equal. Yeah, I think pointing at the 0 is a little annoying because, like, theoretically, you already moved to the 0, and now you want to. Normally, you would move past the character you pull, and we're saying no, leave it at the 0. So if it would just end up staying at a 0, which is better than nothing. I mean, I think this is a touch odd, but I think it fits what you'd want. If you're at the end of the string, it's pointing either at a 0 byte or it's pointing past it to something that doesn't mean anything. Like there's no that pointer is useless to you. So, but we'll experiment in practice and see. It may be that it is useful to have it there for some reason. All right, so I'm pushing a guard value. I push the empty string's address. I call head string. I expect it to put a 0 on the stack and leave everything else alone, not push that second value. Okay, and let's get this in the call list. Actually, I'll put this first. Okay. And this should fail. There we go. Okay, so it's got the junk characters at the front, whatever was in the data stack. Okay, we expect 42. Oh, so the first one passes, yes, but now we've pointed to something. This 43057201, that's a pointer past the end of our string, pointing to probably the start of the CAB, really, or no, it's probably pointing into a block of code here, whatever the code for BL sex space init, or no, BL data stack init, it's pointing in there. Okay, so that's good. I mean, it's what we expect. Okay, so if we pop x0, I guess we don't want to do that first push if compare W1 to 0. If it's equal to 0, we don't want to push. Okay, so look at the byte. If the byte's 0, we're at the end of the string. Don't push the address. Just go down here and push the character we found, which is a 0. Okay. Yeah, I think that'll do it. String, okay. Let's see, add head dollar. And let's document that too, even though it's just us chickens. I guess my fear is if we left it an empty string pushed on the stack, like that would sort of invite an infinite loop. Yeah, it would need to pop it. And yeah, I don't know. It's a little harder to explain this way, so that makes me a little suspicious I'm making a bad choice, but we'll just see how it goes in practice. Okay, let's do a save. Okay. Now we jump back here. Okay, so assert equals strings. Well, I guess he's going to have two strings on the stack and he's going to do it. This is interesting. Well, how do we do equal, right? We walk through the two lists. Oh, you're right. We did not. I don't know what else I can forget about it, but did I spell it wrong? Head dollar is head string. Let's make sure it's head string. I'm wondering if we have a bug in our makefile. Here we go. Okay, and 97 is A. Yeah. Okay, good. Yeah, there's got to be some swapping and stuff. I don't know if we can write this. Maybe we can write this in our language. We should be able to, right? Let's see, up here. There we go. Okay, so we got two strings pushed on the stack. We're going to call. It's crazy. We want to get both their characters in there. Okay, so I'm going to call head dollar, or do I want to do swap head dollar? Okay, let's swap them. So we got stack is high is S1. No, it comes in with S2, S1, etc. Okay, so if I swap them and do head dollar, I now have S1. S1's first S1's first character and S1. So I'm going to do CAB. Well, no, I don't think I need to do it that way. I'll do it this way. Okay, so head dollar puts S2's first character and possibly S2 on the stack. I'm already thinking my my theory about the null string blah 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 is coming back to haunt me already. Okay, because if that thing happens to be an empty string, what happens? Well, then it just pushes one character, and I can't go down 3 characters to do it. So I think it pains me to do it, but I guess that's just a bad rule. Pushes 0. Let's say pushes pointer to empty string and 0. Okay, so this is no longer necessary. Pop x0 should be 0. Well, I guess L empty string. Let's load address. X1 L empty string. Pop x0 should be the string on the bottom of the stack. Okay, so I'm saying whatever it should do, it should point to an empty string. Okay, push the address, call head. We should get a 0 and a value there. Okay. Okay, and then string, well, let's make first, should fail. Oops. I certainly miss rename. Okay, boom, yeah, good. All right, so now string. Well, if it's equal to the end string, I don't know. I feel like I got to do an if statement equivalent, not just an if else. If the byte is 0, I really want to push x0. Well, let's do it this way. Yeah, if not equal, skip a decrement. Okay, that would work. Okay. If it's not equal to 0, we're going to decrement x1, x0. Okay. Okay. If it's not 0, don't do the stop. If it's not 0, don't decrement. Otherwise, push the address we had, and the address, the character, which will be a 0. And leave it pointing back where it was. Okay. Sounds plausible. Oops, did I type an L? Okay, string tests, yeah. Okay, let's try again. Hangman 10 equals string. So, okay, so we got the string on the top. Now we have the character and the string. Okay, I'm going to rotate S1 to the top and do head dollar again. Okay, at this point, and we don't have a comment character. At this point, we've got S2, let's see, S1 sub 0, S1 plus 1, S2 sub 0, S2 plus 1. Okay. And we want to check all right, so now the characters. So I think if we do CAB again, the stack management stuff, okay, now we have S2 sub 0 on top of S1 sub 0. All right, now if they're both 0, well, okay, I think it's so hard to create the framework while you're defining everything. Let's pull out that and let's just do equal string. Okay, so you get those two on the stack. CAB, now we have S2 on top. Okay. And if well, should I do BAC for the second one? No, I'm trying to get the two characters on top. So C is here, the S2 sub 0, S2 sub 0, S1, S1 plus 1. Okay, I mean, I think that's where I am. We may need to swap them around. Yeah, I don't know how to do it in a way to make it clear, but this is the front of the stack, is what I'm saying, the top of the stack. Okay, so now we have those two characters, and well, okay, if they're 0, if they're both 0, we're done, and it's an equal value. If they're equal, we need to continue, and if they're not equal, we're also done. Okay, so I guess I want to compare those two characters. Do I need them once I'm done comparing them? Okay, I'm going to compare them. And then I want to say 0. Well, no, I want to say equal. Yeah. Then I want to do 0. No. All right, I've got a logical expression on the top. I should be able to say if, meaning if those two are equal, Oh, golly. Okay. If they're equal, that's good, but if they're equal to 0, then that's a problem. So I think I got to dupe at least one character. I don't know. Maybe I'd be better off writing it in pseudocode first. But if those characters are equal, okay. Well, let me dupe the character. Well, no, then I can't do the dupe cab. Gives me S2 sub 0, S2 sub 0, S1. The cab would make S1 sub 0, S2 sub 0, S2 sub 0, S1 plus 1, S2 plus 1, etc. Okay, now if I do equals, I get a comparison of these two characters, and if they're equal, I want to do something. If they're not equal, I want to do something else, right? I think if they're not equal, no, I think, golly, can you be any wishy-washy here? I think I'm going to do a while, do odd. Okay. While they're equal, right, that's a good thing. But if well, while I want to say if they're equal and non-zero, I want to continue. Right? Okay, so I've got the logical value on the stack. I want to say while they're equal, and then I want to compare equals 0 and. So if they're equal and then that consumes these two, then the equal 0 consumes this one. If they're equal and both are equal to 0, I want to get out. So it's a not. Did I do bang or just... Now I gotta look. Where's my... No. Let's push this over here. Okay. It is bang. Okay, I want the logical not. All right. Not. Okay. So if they're zero, if they match. Oh, I'm getting this backwards. And they're not 0. Okay. If they match and they're not 0, we should repeat. Okay. Otherwise, we're down here at the bottom. And how do we know if they're... Oh boy, it gets twisty. I need a simpler primitive. Okay, maybe it's back to the length. Like if we just said, is your length equal? Then, I don't know, is that enough? If your length's not equal, you're different. Otherwise, we know we can walk through you similarly. You better be equal all the way or else it's a fail. Okay, so what I'm saying instead is if you're equal and you're not 0, that means there's more characters that we should get. Okay, so the stack at this point equals turns that into 1, equals 0 not turns that into 1, and the and turns those two into one value, and the while consumes it. So we're left with this on the stack, and we should be able to do head dollar then we need to do some sort of swap. So now we have S1 plus 2. First thing is the character at S1 sub 0, or yeah. Well, S1 sub 1, S1 plus 2 is on the stack. Let's swap those. No. Well, somehow I have to get S2 in front, right? So let's do CAB. S2 in front. CAB. And then we do head dollar. All right. We got we have a string S1 prime. We don't care how it gets there. S2 prime. Right, or on the stack. Okay. And character. Character from string 1. Okay. We swap them. Now we have S2 prime, C1, S1 prime. Now we have character 2, S2, C1, S1. And then coming in here, we need 2 characters. All right, so I'm going to do another CAB. Yeah, it would be nice to have some help with this. But I think we could extract it if we wanted to. All right, but now I have C1, C2, S2, S1. And I'm sort of back where I started, but I want to do a dupe because I needed one of the characters twice. In my while loop, I need the 2 unique characters. Yeah. Okay. I'm going to do a dupe. C2, C1, C1, C2, S2, S1, and one more cab. Okay. Because I got to get it the way it was at the start of the loop, which was C2, C1, C1, S2, S1. Now, the interesting thing is I don't care what order the strings are relative to each other, but I've got to make sure the 2 unique the characters from 2 different strings are on top. But I think that puts me to the next thing in the loop. But yeah, I mean, it's kind of weird because we're managing 2 strings at the same time. It gets a little goofy. But I'm afraid we still don't have enough information is the real thing. So this consumes it all, and then at the end we're left with presumably 2 S0 string, 2 strings both pointing to 0. Because if one came up empty, we would exit the loop. All right. But I think that the thing is, Yeah, I don't know. This is maybe this helper you got in mind would be a better thing. I mean, head dollar gets you the next character. That part's fine, but managing it with two of them on the list, on the stack, is really troubling. Now, it may be, I don't know, like if I had a routine that was like dupe dupe that would take C1 S1 and turn it into C1 S1 C1 S1 or something like that, or dupe 2 or something, that would simplify some of this and it might make it better. Okay, but let's suppose this worked. I think it's ready. It gets the three characters on the stack with the two different ones first. Yeah, no, definitely a secondary for that. Um, but I think part of the challenge is because we have to do all this cab stuff because of the way it. Um, yeah, I don't know. Hmm. Okay, but at the top of the loop we had this structure, and I think that's fine. When we exit the loop, I think all that got consumed. So we've lost information. So now we got um, S1, S2, at least one empty. Um, yeah, variables do make it easier. But I think there's also the no. I mean, primitives make it easier too. um, in the sense that the right primitives would help. I mean, cab dupe cab, right? That sounds like it's doing something specific. Um, which it's sort of. I mean, it is doing something specific, but there's something in it to it. I don't know. I'm gonna push through this thing at the end here. Okay, so I think if I do, I know at least one of those is empty, and then if somehow this should be pushing a 1 or a 0. Okay, at the end of the whole thing, the stuff stack should be cleaned off and this thing should be pushing that. So I'm left with two strings. Well, I don't know. It's crazy. I'm left with two strings. If I do head dollar, cab, head dollar, and this may be a good place for a helper because we've seen that pattern before. But at that point I have C. Let's see. So here I have C1 S1 S2. Here I have S2 C1 S1, and then C2 S2 C1 S1. Okay. Yeah. I'm getting weird messages about the chat room. That makes me wonder. The other day, it apparently restarted the chat or restarted the recording about 15 times. All right. And if I do one more CAB, okay, I'm going to have C1, C2, S2, S1. All right. And now it's kind of this again. Which maybe means something, but whoops. Okay, equals. So I want to find out if they're equal and one of them Dupe cab. C1, C2. Well, no. Do I need that? Okay, if they're equals. Oh, maybe that's enough. Take the first character. If they're both. Oh, maybe it's not even that. No, I guess we don't know if it points to an empty string. We don't know if it points to the same empty string. So, yeah, okay. But if the characters are equal, then they're both zeros, because we know if they were non-zero, they'd be in the loop still. Okay, so we know they're equal. So the if, well, I don't know. I think pop, whoops, pop those two strings off. Okay. Can I paste this? And then we'll work on making it better. This is my first time using this language, you know. I'm not going to get everything right the first time. Oh. I can't paste. Oh, it's after that first slash. No, yeah. Stack. Yeah. Okay. Yeah, I don't think there's enough expertise yet. You don't know if you move past the end of one of the strings twice. Yeah, that's the thing. I don't want to do it twice. Right, if they're equal and they're not equal 0, then they're equal strings so far. So we keep going. We get out, and now we've consumed the first two characters. We kept the third one around just to be the match. Oh, well, maybe that's the thing I should look at. Okay, maybe. All right. Okay, so I think this point I'm at is this is okay. I'm only going to look at the first two characters. Oh, no, that's that one. Subtract both string pointers by one first. Well, but then head dollars, I don't think you can trust that string. Like, you don't know where that's pointing if you go outside its range. I think the thing I'm trying to get is I need if I can get this character left on top. I don't know if I can get all four of these. I mean, I've got it here. What if I did another dupe? These patterns mean something. Okay, if I dupe, I've got S2 sub 0, S1 sub 0, S1, I'll say prime again, S2 prime. And And it's S2 0 twice. Do a double dupe, and if they're different, pop it. Yeah, something like, yeah, maybe that's it. Is like a, let's define dupe 2. And it's gonna, if you got AB on the stack, it's gonna put AB on the stack. All right, so got AB, etc. All right, so we dupe. That gives us AAB. Cab. Is cab the right thing? BAA. Dupe. No, I'm down to too far. AB. Let's do the cab first. Cab. Nope. Swap. Dupe. That gives me BA, BBA. Cab gives me ABB. Dupe gives me AABB. And if I do cab, I get the B in front. I really want ACB. Do we have one like that? BAB. AB goes to BAB. Oh, that's a good one. Okay. BAB gives us BAB on the stack. If I swap, gives me ABB. Dupe gives me AABB. And I want ACB. It's almost like a swap too, or swap. Well, ABC. Well, let's do that one first. We'll find out all the ones. ACB is well, it's really cab swap, right? Okay, so given ABC on the stack, this produces CAB on the stack, and this produces ACB. Okay. I think that's simple enough. I can put it in one line. If I can type. Okay. All right. Now, dupe 2, I want my ACB here. All right. So BAB is BAB, then ABB, dupe is AABB, and then ACB pulls the third into the middle. Okay. That's good. Yeah. All right. Let's take out these comments. Let's see if I can do a copy paste into the REPL. Well, he didn't blow up. BAB not found. Swap not found. Dupe not found. Oh, it's probably tabs suck for it. That's what it is. Oh, I really don't want to worry about tab versus space. Well, maybe we got to. All right. Is this rebel? No, it's read word. B and E. If it's not a space, look for a string. If it is a space, increment and then keep going until it's not a space. Okay. Yeah. If it's a space, well, I think I'm going to flip the logic around first. So if it is a space, we're going to do this stuff. Well, I'm refactoring for a moment here. Okay, is that the same? If it's a space, we're going to go add a word, increment to the next word, and go back and try and find the word start. Otherwise, it's not a space. Then we're going to skip forward to look for string and then look for a word. Okay, so I think that's a refactoring. Make that. And then let's find our IOs. IO tests. Mail. Okay, let's make sure rebel.out. Okay. If I say tab 1 dupe. Yeah. Okay. But if I say space 1 dupe, or even space 1 dupe, 1, good. And if I do a pop and a dot, it's still 1. Okay. No, jump's not an alias. Okay. So now I think we can, if it's equal to space jump to move forward, I think the same thing is true if it's equal to a tab. So I think we've structured it in a way that makes it easy to add that next condition. It's a little weird to be branch, but I don't think it's wrong per se. All right, so let's see. So this was refactor read word. All right, and now I want to find a test for read word. Should be input tests. Okay. somewhere we should see something about a space. Read word starting a space is okay. Yeah, let's and read source 2. Well, let's make a read source tabs. Okay, so we input initialize, we read source tabs, we read word, and then we check that the word it found is the expect source tabs. Make sure I call them that. Read source tabs, read source expected. Okay, and this test should fail. Input tests. Okay, boom. All right, and it found, yeah, there's something there. It's a tab. Okay. Input s. All right, so now this structure starts paying because we can sort of do the or clause out of this. If it's a space or tab is control I is at 8, A, B, C, D, E, F, G, H, I, 9? Ten? No, 10 is line feed. Control J is 10. Yeah. So control I is 9. Okay, I'll get there. But anyway, if we see a tab, we're also going to skip over it, and you could see we could add more if we needed to, but I'm not gonna bother. All right, so this should pass. Was input tests? Ooh, something's still wrong. Okay. Well, let's look at the test first. I don't see a problem with that per se. All right. This one. Okay, we'll run. Is it underscore? No. So I'm going to continue. All right, so we're in read word. All right, I guess we're just going to do some skipping. Next instruction should be back here to 3D50. Next instruction back here. Let's see where we are. We just called string length. Oh, we're in. I'm confused. Are we in the find routine? Okay, we're back. Read word plus 20. Okay. So, okay, it's a 9. EQ, we're going to jump. Okay, so we'll step. It's not, so we compare it to 9. EQ, we jump a little bit. 3 of 30. Okay. Add 1. That seems good. Back here. 3 of 18. Well, the first one worked. Then I have two spaces, 2 tabs, and a little more. Well, this one should be, so we should skip down to 3 of 30. Good. This one should be another space. 3 of 30, good. Should be a tab. 3 of 30, good. And then one more tab. And it should be a 3 of 30. Good. Okay, so that gets us to the W. We just added 1. Oh, okay. Yeah, this one should. Okay, we got a step. Get the next one. $77, that's in the range 65 up, so it's. I guess I would have thought it would. Is that a W? It seems a little 22 after A. I guess that could be W, yeah. All right, well, step. All right, now this should fail. This should fail. And we jump forward. Okay, and now we're in look for string. It's 77, so it's not 22. All right, now we're in the read word. This. Well, I don't know. It seems to have skipped that stuff as you'd expect. It's not looking up in the dictionary at this point. All right, I'm just going to continue. Am I missing a new line? Oh, good point. Yep. Okay, thank you. All right, well, good catch. And let's check this in and then we'll take a break. So skip tabs as well as spaces. All right, so yeah, let's take a break, see in 3 or 4 minutes, and we'll come back and see where we can go from here. Welcome back. Okay. we're stacked multiple layers in here. So the reason we just implemented that was because this was so annoying. And we'll see if maybe cut and paste has the same issue as our file redirect. I don't know. That seems... I'm going to do a make clean and a make. Make REPL, paste. Oh, well, ACB I defined, but why is the semicolon not? Let's try grabbing everything. Okay, a touch weird. Yeah, I'd have to say a touch weird. Oh, maybe the semicolon terminated but didn't hit return, and I had to do that to get out, I think. Okay, kind of believable. All right, so now ACB, if we do 1, 2, 3, ACB, we should get 132 dot 3. Well, that seems wrong. ACB, so we do ABC, we do CAB, we get ACB. That feels right to me. All right, let's try 1, 2, well, let's do 4, 5, 6, AC, CAB. And we should get 6 on the top. Should be 6, 4, 5. What? CAB. Everything's got to be hard, right? Okay. 4, 5, 6. 4.5. Oh, it comes out backwards. Okay. 3, 2, 1, CAB dot should be 3, 1, 2. Okay, pop should be 1. Pop should be 2. Okay, CAB works. All right, now do 3, 2, 1. Well, no, let's do 4, 5, 6. ACB. Okay, so A is 6. It should have 6 on the top, then 4, then 5. So we'll dot pop should be 6 dot pop 4 dot pop 5. Okay. All right. So I think ACB seems to work. Dupe 2. 2030 dupe 2 dot should be 30 20 30 20. So dot should be 30. Pop dot should be 20. Pop dot should be 30. Pop dot 20. Okay. So cut and paste seems to work. Getting rid of tabs seems to work. The 2 routines we defined seem to work. That's something. All right. Now can we use that? Okay. I don't know. I want to go back and trim this down. If we can make things easier. I guess, I don't know. If we did head dollar CAB, let's keep track of these. I'm going to want a comment thing before this is done to the rate we're going here. Okay, so this is S2, S1. So head dollar is C for 2, S2 prime, S1. Still there. Cab is S1, C2, S2 prime. And then head dollar is I'll call it C1, S1 prime, C2, S2 prime. Okay. And so I think what I'd like to have is C2, C1, S2, S1. But I can live with the strings in either order. So if I do a cab, okay, so a cab gets me C2, C1, S1 prime, S2 prime. Okay, now I think I can do a dupe 2 here and get C2, C1, S1 prime, S2 prime. Sorry, C2, C1, S1 prime, S2 prime. Okay, now that seems to be kind of what we want. Okay, so we'll do while equals and not 0. Then we come in here and we've got the extra copies. Oh no, we've got the 1 extra character. Okay, so we get in here. Yeah, we got C1, C1, S1 prime, S2 prime. And I don't know, I feel like I'm missing CBA. Would that be a good one? So, all right, CBA would rotate. Well, no. Yeah, it flips the top three stack. CBA turns this into S2 prime, S1 prime, C1. But that's not what I want. Okay, I think the thing to do is pull this out and say, you give me two strings on the stack, I will give you their two characters and the following two things on the stack. You do what you want with them. Okay, so let's pull that out. And I'm going to call it head $2. Okay, and these four instructions do that. Okay, take the head, take the cab, take the head, take the cab, and that stuff should be head $2 should do that. Okay. And we're not specifying which character has to be on the front or the back or the whatever. Okay. S2, S1, dot, dot, dot. Okay, do you want to check C1 here? Okay, so I don't feel like I don't think I need to, but I think I need to do something here. I think I almost want to just drop it because when I get here, maybe I should make the sort of assertion. Characters are equal and not zero. Okay, means I should go through. If they're equal and not zero, then all I should do is get the next thing. All right. Now, the next thing, I think head $2. I've got, what do I have on the stack? I've got, well, I consumed the top three characters, so I'm going to do a pop to get rid of that character that I don't want. And then I'm going to do head $2 again. Okay, so given this leaves S1 prime, S2 prime on the stack because it was just these three. And now I've got C1, C2, S1 prime, S2 prime. I don't care which order, but I've got some combination of those. And that feels like where I am from before, except for dupe 2. All right, so I think this just cut it down. Yeah, dupe 2 again. So we get the top two characters, we duplicate them so that we can use the while can look at them, and he leaves the character on the stack, but he checks the first three characters together form that condition, and he dumps it because he already doesn't need it anymore. He knows he's moving forward. So I think that's the while loop is okay. And now down at the bottom, I've got one character on the stack, and I know they were not equal. Maybe I need two characters on the stack. Because I know if they're, one of them could be a 0, in which case the if the other one's 0, it's fine, but I only have one character to look at, so that can't be right. Okay. Can I move them both into the while? Well, I mean, I need something on top of the stack to start with, right? So, well, the while is kind of the condition, right? So it's really evaluating, like you leave the stack ready so the while can evaluate the condition based on the top of the stack. You can have other stuff pushed beneath it, and that's fine. But here at head 2, I've got C2, C1. I call dupe 2. I'm going to call dupe 2 again. I just think I need that much stuff. So this consumes the first 3 characters. Oops. Okay. And then I get in here and I've got 3 characters I don't want. Okay. And I get myself down to just the 2 strings. And dupe 2, do I have to do it again? I guess. I got to be consistent but when I come out, I've got 3 characters on the stack. And they're C1, well, C2, C1, C2, C1. They're alternating. I only need 2. Okay. Now, if those 2 characters are empty, now I've got the 2 characters on the stack. So I duplicated, so I would have 3, the bottom 3 coming out. I don't do head 2 until I've cleaned those off. So now I have C1, C2. I popped one, so I have C2, C1. And I want to say if those 2 are equal, equals if, yeah, I think that's where I'm getting down here. If they're equal, I've got S1, S2. I pop those off and return 1. Otherwise, I pop and return 0. Okay. It's a little better, but okay. So if the characters are equal, then they must both be 0. Because the and on the loop was equal and not 0. No, are they? But if they're equal, well, either equal or not 0 failed. So if equal failed, then we go to the else clause down below. If it not 0 failed, am I still not right? Oh, if they're both 0, we will exit the while with 2 characters on top. And if they are both equal, then we return 1 because the strings were equal all the way through. If they're not both equal, one was a 0 and one was a non-zero, or one was A and one was X, either way, we fail and we'll pop the 2 strings and go. Okay. If you exit, if they're different or both 0, yeah. So I think if they're equal, the only way they're equal is if they were both 0. So that would be this case, in which case they were equal all the way across, and now they're equal. Otherwise, they weren't equal. Either one was 0 or one was something else, and we'll do that. Okay, so I think I have equal dollar. Now, what's in our rep? Okay, nothing. All right, so let's do this. Oh, I got to take these out. I'd really be well served by an end of line comment, wouldn't I? Let me add that to the to-do as a possibility. Okay. Let's see, what did we do? We did head dollar. Implemented head dollar. Splits off first character of a string. And we made skip over tabs like we do spaces. Okay, that's something. All right, now what we're really trying to, right now we're working on equal dollar as a user written thing. Okay, so let's go find that. I'm going to take all this stuff. Oh, I got to take these out. They're really useful. uh, um, yeah, maybe we got to do a, like, I don't know. We haven't used twiddle yet. Like if they just all said twiddle and this, um, I want to use a one character thing, and all the good characters are taken. Do we use twiddle already? Where's our logical? We did. Okay, what am I left with? Back quote. That's almost like small talk. Let's do it. Let's do back quote. Backtick. Okay. We're back to strings. No, we're back to input. Input.s, input tests. Okay. So I guess I'll go by the test names. Okay, let's try that. Put that down here somewhere. Read word. Okay. Backtick comment. And this is almost like a new line test. Yeah, yeah. Maybe we got to do the same. Whoops. Let's find that multi-line. This, excuse me, this test is going to be really close. Okay, we're going to read something. Okay, it's got the two lines. And then we read with our stub. And we expect read multi-line 1. Okay, I think that's going to be the same kind of deal because it's supposed to act just like one. All right. Where's that multi-line? Okay. Well, this really belongs up there. We'll call this a backtick line. All right, and he can have spaces, and then he says a comment. And then the non-empty is a 1. You need to be able to ignore what I tried to be able to have multiple lines. Yeah, I think, I mean, really, if I, just like I do in the new line, I hit the new line, I go read a new line. I think the same thing's going to happen here. Non-empty, let's just say word. I expect word. Okay, backtick line, backtick not empty, backtick expected, expect backtick. Okay, backtick line. And if we see a comment coming, I think what we'll get is an ignored word and it won't match the backtick. Or we'll get the backtick maybe, backtick A, probably. Make. This is input. Okay, reads whole string. What? I think there's stuff carrying over between these if you don't consume them. Let's make it work. I'm going to move this one down temporarily just to verify that it gets screwed up too. Well, it doesn't. But I think it's a interaction between tests. I'm not going to sweat it too much. Okay. The test we want to fail fails. I think fixing it will fix the other. If not, we'll learn something. Okay. Create comment end line. It just found the quote. I thought. Oh, I have space A. Okay. Okay. Alrighty. So input. Where's read word? Here we go. If we're at the end of the string, then we do get a new line. Okay. Those we're finding the word start. Find trailing space or new line. Okay, I think it's the same thing as this. whatever that was. I'm a little confused by this code, though. Comparing to space also jumps to exit word. Oh, because we found the word. Okay. So if we find a new line, well, let's look for. I think just skip to the end of the line. I don't think I need to search further. We'll just zap a 0. Don't ignore the rest because it will read more. Yeah, I think the new line, we just zap it with 0. We'll see. Let's maybe put a little extra. No, I don't want to put extra there. Okay. Well, I need an ASCII chart. Good old 96. Good old 60. Okay. Well, I think I'm supposed to, if I come here, I don't know. I don't think this will quite work because I think there's, I think we'll set that character to 0. Normally we have this double 0 thing going at the end because of the new line followed by a 0 and we've zapped it. So I am not completely confident this gets around that. Okay, back. X0 equals 0, x1 equals 1. X1 is word. Yeah. Maybe it's here. If we're not equal to new line, find trailing space. Yeah, I think if you want to find the start of a word, well, no, if you're okay, so we keep going. If we hit a new line here, B not equal, we find the trailing space. It seems weird. I mean, maybe Backtick needs to zap the character after. Would that do it? Fine, back. Okay, you're looking for a word. You load the byte. If it's not a new line, wait a minute. Why is this not equal new line? If you're not equal to new line, find a trailing space. I'm missing the loop here somewhere. Sorry. I mean, it would be easy enough to say, oh, you're a backtick. Let's zap the next character too. But I'm not quite clear how this adds up to match the comment. At the end of the line, go back and read more. Okay, so next word equals next word plus one, check at end. If you're not equal to new line, yeah, I don't think this is the right place exactly, because find trailing space or new line. If you find a space, you jump to exit word. That just feels wrong. Oh, are we trimming the trailing stuff? I don't know. Next word checks if it's a zero. Yeah. I mean, if you're looking for the start of a word, you've got next word and word found. You load the byte at next word. If it's a new line, then we add one and check at end. If it's not, this is the one that's throwing me, I guess. If we saying exit word, if it's a space. Okay, so is this, where's the loop? Right? Somewhere there's a loop that's going to be next word. Okay, this is move forward. Okay, we're finding the start of a word. We skip over spaces and tabs and keep going until we find something that's not a space or a tab. But, like, couldn't it be a new line at this point? Okay. If it's a new line, we increment and then go back to check at end. Right. Okay. So I feel like if it's not a new line, we jump here. If it is a new line, we jump here. Mac one space. Yeah, I mean, I think if I can get the right position here, if I find a new line, I'm going to move to the next character, which is that zero. So that's the end of line and it's good. But if it's not that, see, I've got the same kind of conditions here. I don't know. I'm going to have to think about this exit word thing. I think I think we're trying to peel off trailing spaces, eliminate trailing spaces. Read next word plus one. So peek ahead a little bit. If it's a new line, exit because we're done. If it's a space, we're done. If it's a backtick, we're done. That seems right. The trick though is we're not checking for backspace up here, so it's going to just consume it as a regular word. Yeah, we need to check it somewhere in here. I mean, if it is okay, let's do that. If it is 60 backtick branch equal to let's do L handle backtick. Okay, and put that down here after the branch. Handle backtick. Okay, now what are we going to do? The new line one just doesn't add next word. But I think the backtick has to do what you suggested. And it's going to zap. Well, I think it's going to have to do a store byte WCR into next word. Okay, so it's a backtick. Move back one step and zap itself. Yeah, so next word is still pointing to the current character. So I think we're zapping the back tick, and then I think we want to increment it, and then zap the next one too. And then like this one, we're gonna do that. So the new line. Okay, find trailing space or new line. And then I think we have to do the same as this, because we want to make it read if it needs to. Okay, so let's check this, because the case for the new line always has the 0 after it. Okay, so check at end. Yeah, if we come back up here and it's a 0, then it's time to read line. So we're sort of forcing that, although we could let's try it that way. Okay, so next word left at the 0. And we'll check that. It is the 0, read the stuff, do it. Okay, so now let's check this fine trailing space. I guess we're just at the end of the word. We know we're at the end of the word at that point. We look at the next character. We're peeking at the next character. Oh, it's one of those things. Then get out of here. And then when you come back in, it should be looking forward for that. I don't know. I'm right on the edge of competence here, I think. Okay, good sign. All right. And that fixed that second test. Okay, so let's just do a little checking here at the REPL. Back quote, nothing. I'm still wondering if this thing is make REPL. Back quote, nothing. Something in our make file is not picking up. I don't. Maybe it's input. REPL.out depends on input. Special meaning bash. Yeah, I don't know. I think it should be okay. This comment 1, 2, comment 3 dot no plus dot. Okay. Well, that didn't distinguish it, did it? 10, 20, 30, 10, 20, 30 plus dot should be 30. No. Times dot. Okay. So I can't tell why this thing, the make REPL doesn't seem to pick up. Oh, no, REPL.out depends on everything, doesn't it? But I think it did. I don't know. There's a make problem that it's not picking up when I changed input.o. It didn't rebuild REPL. Yeah, don't know. Okay. All right. So this is add backtick for comments. Okay. Now let's change these to backticks. And replace with backtick. Okay. All right, now this equals is admittedly obnoxious. Oh, end is not the right word. If else fee. I should just be able to pick up from here. Okay. It's like it's not ignoring those end of line marks though, isn't it? We're not found in. Yeah, it's really like it's not ignoring those. All right. Let's just do that line. Yeah, we used a bound for something, but yeah, you're right. That's probably a better comment character. We could switch it out. All right, so it's clearly not ignoring to end of line here, though. I don't know how to interpret that. Input. Is it the issue that it's got characters in front and we're not handling the end of line? That sounds like it. Let's change our test. Make it a little more robust. Okay. Word 1, a comment. And word 2, and this is backtick 1, backtick 2. Okay, backtick line should have word 1 in it. Okay, so I'm going to have to call read word twice. Backtick 1. So it's going to be one of these funny ones. Act and assert. Okay, so we'll repeat the read word. So we should be able to read 2 words and find them. And I think what we're going to find is we get the first word, and then the second time he hasn't skipped to the end of the line. He's maybe only skipped somewhere. No, I think read word is used by compile. Oh, that's right. That could be interesting. Well, compile colon reads the next word, but I think it's all the same read word that it's calling. So I don't think that's the case. I think the problem is we have our test case, our manual test case had this was after you found a word and you're looking for the end of line. I don't think we got there properly. Even though we kind of zapped these 2 characters, I think maybe I left, either I moved a pointer not far enough or something. Okay, but this test should be tougher. Input. Well, apparently it's not tough enough. All right, so I guess the thing to check, okay, make clean, make REPL. If I do 1, 2, 3, backtick in, I want to spell it the same way I did over here. Oh, tab, quote. Tab, backtick, space in. X. Yeah, that has the tab on it. Oh, maybe our tab stuff is not correct or sufficient, right? Because we checked for space. Yeah. I don't think we checked for space everywhere you check for space is the problem. We checked for this case, but this case we did not. Okay. OX09 is tab. Okay, that's fine. 1, 2, 3, tab, quote, in, plus dot 5 plus dot 6. Okay. All right, so it was really the tab creating the problem. Make sure you can use tabs before backtick. Okay, well, we're out of time, so we'll stop there. Well, we made a start. I mean, I think we're learning a little about how to write this thing. We're finding some holes in what we did, and I think we'll pick up tomorrow. We'll do a manual test of equal string here, and then we'll work on developing an assertEqual string, which shouldn't be too bad, and then we'll work our way up to testing the title. But yeah, good place to stop. All right, well, next time is 2 to 4:30 tomorrow. It's Eastern Time, or 6 to 8:30 p.m. UTC. Thanks for joining today. Thanks for the help, Mudshark666 in particular, and have a good evening, and see you sometime in the future, I hope. Bye-bye.